Hello guys, this is actually a set of videos, maybe be one or two, I'm not sure yet. It'll be part one and possibly part two. This is something that rolled out over week 7 and 8. This one lesson, there's some involved changes in this code, and I decided to do a full-length video of these changes. What we're going to do is, right now, I have a code set up here. What happens right now when we run our program, I'm going to compile this and bring it up, is that we're doing this. We get message. And what get message is doing is it's getting a message for us, and then it waits for, so when we get a message, we're actually sitting there waiting for the user to do something. Well, in a game, if the user doesn't do something, usually it doesn't go real well for the user, because you know the whole thing about the game is to get, if the user, we want to react to the user, and if the user doesn't want to do anything, then see, like right now, I can hit the 6 key, I can hold down the 6 key, the 3 key, and I can do stuff right now. But if I don't do nothing, I'll just sit here. And it's like, well, what if we said the last thing we wanted to do was, if we hit the 2 key, then we want to keep going that direction? Well, then we have to do something different than just get message, because all get message does inside C++ and Windows is sit there and say, well, we're going to wait for the user to do something. Well, we're going to change that up today. Instead of saying waiting for the user to do something, well, we're going to see if the user did something. If the user didn't do something, then we're still want to go ahead and do something. Okay, we want to do something to the user or to the game, whether it's motion in the game, whether it's moving boundaries or anything else like that. We want to keep the game moving, and if the user doesn't react, then it may involve some sort of consequence for the user to not interact with the game, or make the user pause the game and saying, no, I am taking a break. Still give the user the ability to pause, but instead of getting the message, we're going to be like this kitty cat here, peeking around the corner of the couch. We're going to go and peek to see if the message, if there is a message. If there is a message, we're going to remove it, and then we're going to translate the message, and we're going to go ahead and dispatch the message just like we do now. And if the message is quit or break, we're going to go ahead and get out of this loop, but we're going to put a do while true loop around this, and kind of like going, we're going to peek and see if the user did something. And if they said quit or destroy the window, then we're going to go ahead and get out of this loop here. We're going to say we're out. Okay, they want to quit, so not a big deal. Let's get out of the loop. So that's no big deal, but if they don't, then I want to do something to them. Now, I'm going to introduce some code today that allows the car to keep moving according to the last direction they moved. But again, this allows us to move stuff in the field. If there's monsters can come in and attack. Things can still move. Clouds can move across the sky. Whatever it is for you guys that you want your game to do, your game can still be rolling forward if the user's doing nothing. And you can begin to provoke the user to do something. So that's something to think about. So how do we make the code modifications? Well, on page 2 of this week's document, I pretty much gave you a little bit of a gift, because the reason why I gave you a gift this week was, here's pretty much we go ahead and peek for the message, and then we see they said quit, and then we have to repeat it once we get outside of that loop. But then we need this thing right here, if play equals 1. That's something new, because it's like, okay, before we can implement this, we have to be able to know, are we playing or are we not? Because if we're playing, we want to change our keep moving. This is if we're playing, then we're going to go ahead and do all this. If we're not playing, then we're going to go ahead and initialize the game and say, hey, are you ready to play? And then we're going to sleep 50 milliseconds. And so we see this sleep command come back of like going, now, if we say sleep 2 milliseconds, then we're going to see things move a lot faster. But there's two things that we see here. One is direction. Now, let me show you about direction. Before, in the old days, before today, direction was a local variable here. You with me? I'm going to pull up the other copy. I have a completed copy over here that I get to pull up as a cheat. You guys can't see it, but I just want to make sure we get this correct for efficiency's sake. So, and also we were setting the case to 0. So, one, we no longer want to set the case to 0. And we no longer want to initialize direction, because the integer direction, dir, is now something that we need to move. And I'm going to comment these out here so we know that these are changes that we've made today. We're going to add dir up here, and we're also going to add another variable play, because direction is now something that is global throughout the entire program, because not only is direction being set in the WM key down section of the code, which is under the L result. That's the part that gets called once we capture a key. The L result is the thing that the Windows 32 API says when we dispatch the message L result. And in L result, we had the local variable direction. Well, we now need the direction up here too. So we're moving direction up in the program. We've just done that, up into the global area. And we also need this variable called play. So there's a lot of little tweaks here in the game. And so what we're going to do now is we can just go ahead and grab this code right here, right? And say copy. Now, if you have a PDF, there's actually two little files out there that you can actually grab the code, and we're going to take this here. Now, you still need this line. One of the mistakes was some of the students deleted this message line. This defines a message type variable called message and initializes it to nothing. So we're going to take all this here and replace it now with the code in the handout. And it already says we have an error. And look at the error right here, check objects. Notice that check objects no longer has a parameter passed to it. So we've already generated an error. Well, it's pretty simple to deal with that. Before, in the code check objects, we were passing it the direction that we were going to go. In check objects was receiving a direction. Well, we don't have to pass direction anymore, right? Because it's a global variable. Now I could throw direction in there, but it's better and it's more efficient if we just go in and make check objects. So double checking the answer key here. Check objects is, yep, it is no longer parameterized because we're no longer passing direction. We are just keeping track of direction. So then we drop down to check objects. That should generate an error down here quickly. And then, so we no longer have direction past here because that's a global variable. So that's the next kind of modification there. Now, okay, so that's just a cut paste, but again, modifying those two variables was this is a sample. Notice if we hit a brick wall, we now have to tell it when we hit the brick wall that we have to set our direction equal to 0 and our play equal to 0, because and then we have to destroy the HW car. And so it also changes how we react now. What's our error? We have another error. Oh, this check objects is also changed. Duh. Okay. And that code will also change. And so when we run into the brick wall now, down here in check objects, we have to add a little bit more code. So did we win in a couple of things like that? But we've made some major modifications. We've changed check objects. We don't have any errors. Let's just see what it does right now. And it's going to do some pretty goofy stuff. But let's just do a compilation check and see what the result change is, because the next set of work is going to be in check objects. Let's see if it compiles. Holy smokes, we got the screen up here. Good deal. Good deal. Good deal. All right. So we're going to put in some data. It's going to tell us we know how to enter data now. Now it's still stopping, but the game itself still works. We're still able to hit objects, and if we hit a wall, we still die. So, okay, that's so basically we've inserted this code. There's no functional change, but the game still works, but we're not getting this play equals 1 working, right? So where do we have to set that? Well, first off, if we do let's play init, we want to set play to automatic. So when we do let's play init, that's when we now want to say, which let's play init is up here. That's let's play refresh, but let's play init. We want to say we are now playing the game, right? So if we set play equal to 1, it's not uppercase. Now this will show us what happens when let's play init sets it to 1. Well, there's another thing that we have to take care of here, is that if we hit a brick wall and we have to start over, if we hit a hay bale, I don't think there's a big change, but if we hit a brick wall and we have to start over, we have to add these 3 lines of code to these. So we have to set the play to 0, because if we hit the brick wall, we have to stop play, we have to set the direction to 0, and we have to destroy the car. So anywhere where we hit the brick wall, I'm going to go ahead and add these 3 lines of code. I guess we'll just, we'll do it here. Hang on. Yeah, let's see. Let's grab these here. And again, there's several minor changes here, and that's why I wanted to do the full video of this. Destroy the car. And we're going to have a little extra here, so we won't destroy the car twice. Okay. And right here. And then now we have to destroy the car twice again, and we'll clean that up. So now let's see what that does. So if we hit the brick wall, that happens. And also if we win, did we win? Notice that we have to also set the direction to 0. We have to set play back to 0, right? Because we're stopping play. So, and we're going to destroy the car. So, because let's play Knit's going to redraw the car, right? So we want to be able to do that. So let's see what happens now. And now I'm going to, let's see, type my entire name in here, tab, and that don't work. 5, and say done. And then let's see what happens. Notice I just hit the key. See, my hands are up here. The car is still moving now because I just hit one key. See, and it's not relenting. See, hands free. It just keeps going and going and going, and that gets trickier there. But we still win the game. So now we see again that now watch this. Here's the crazy part. We have a couple more things to do to wrap this up. But the other thing that we're able to do now, which is kind of fun, is Tim, your game is kind of slow. So let's make this 20. Okay. So what are we doing? We're reducing the interval that we're waiting. Before it's like, okay, you're not going to do nothing, I'll do something to you. But then I'll give you a break, right? We'll give you 50 milliseconds, right? Not a whole lot. But now he said that was boring. So now we're going to give you 20 milliseconds. And I think one timing, and so you see how that moves even faster now? And then so the actual time it takes but it's easier to hit the wall. All right. So, but now that all seems to be working real good. Let's see if we can get this to work. Oh, we hit the wall. Okay. Anyway, it still works. But I'm going to set that back to 40 while we're testing because I'm the one doing the testing. You can set that to anything you want. Later on in one of the future lessons, we will make that variable depending on what level you are in the game. All right? So we can move on with that. All right, so let's go back and look at the source document that's out there in Dropbox. So that's another modification, but also we've changed check objects. We've also let's play refresh, but we want to go to in L result. We're going to go over to L result here. The big difference here in L result is if hang on. L result is right there. And right here, it's this section right here where we had let's play refresh. Well, check objects can now say we're going to kill you. You can die in check objects. And play may not be set to 0 when you die. And so what we need to be able to do is make sure if play is set to 0 that we run let's play knit. And so where we had check out let's play refresh, we now need to put in this. So we need to take this code right here and we come right in here and put it in here. Okay? Now, what that does is play is, when we take play and compare it to 1, that's a double equal sign, we're doing a comparison there. If this returns true, then this if statement is true because of this equals comparator. Notice it's not a single equals like up here. If we're doing an assignment, it's a comparator. So, and if play is 0, then we're going to go ahead and run let's play knit and ask them if they want to start over again. Now, then there's one other thing that was making it kind of work before, is that if they hit the brick wall, I think we had something here, if they hit the brick wall, and we say direction and play is 0, direction is play 0, direction is 0, play 0, direction is 0. Okay, so all that's turned off. If you hit the hay bale, of course, play is not stopped, play continues. Now let me point a couple things out in Dropbox here. There are some new bitmaps. So in BMPICO, if you look, there is now a car with a green background in every one of these. So we've had the ones with the white background, but what we eventually want for everybody is that you have one with the green background, so that the green background. Now notice that the car that goes to direction 6, it's a lot skinnier, and so you're going to have to modify the size of your image for the one that goes that direction. We should probably make 4 the same way, but I want to show you how we're going to roll this out. So I'm going to copy these in, and I'm going to go to my repos directory because I'm in Windows 07B. So I'm going to go over to repos, Windows 7B, and I'm in the directory that has the same directory as my CPP. I'm going to say paste. I'm going to put all. There were 2 that were already there. I'm just going to replace them all. I'm going to say yes to that question. And notice that before we had the RC1G, we had RC1 before, now it's RC1G. So all we really have to do is go down here, and we should just have to put a G here. And then let's see what's the right one for 6. Okay, so we're going to put 6G here. So RC car 6G. Let's see if this says anything. I just want to see if this works real quick. Now this isn't going to work right, because we have to do modification here on this one line for RC6G, because RC6G, if we go look at it, properties, if we're going to go view, let's just go medium icons, we're going to see RC6G here, 3, 4, 5, there's 6G. 6G is skinnier than the old 6G. So I'm going to show you how to fix that real quick. So we're going to say 5 and 5, because we're just going to do this real quick just to demo this. But what that does is that gives you some green. Okay. So that's the normal looking one, but you can see 6G. Now notice that everything has a green background, but this one is really wide. So for when we make them skinnier, so we don't have the green overshadowing the area, so we have a shorter Y component to it, and you can actually make this half of what it was here. So it actually loads 60 wide. But there's one other modification we need to make. So let me close this and explain this. So when we're going direction 6, look at the sensors. We had the sensors laid out over 120 before. Now the front of the box is actually 60, the middle of which is 30. So when we actually go and look at our direction for 6, we have to look at our sensors on the Y. See, we had 50, 70, and 90. So all the sensors were in the middle of the box. But really what we want to do now is the box is now 60 wide instead of 110. So we've cut that in half. We got rid of all the extra green. So it looks kind of nicer when we're going past an object. So all we want to do is I want to move right here, put this sensor 10 over, put this sensor here at 30. So I'm just moving the sensor, and I'm putting another sensor over there at 50. And I have to do that when we hit the wall, but I also have to do that when we hit the hay bales. We'll eventually clean this code up in the future, but that's just not on our list right now. And so then I'm going to make this 50. So what I did is I brought a skinnier image in. Okay. Now you guys can take any of these images and get rid. Now notice ASG is going up and it's skinnier, but 8G is not. Okay. So if you want to change your code to use ASG, then you load the object so it's skinnier, but then you also have to change your sensors across the front of the card. Does that make sense? So just like we did here. So let's see if this works now. So we're loading the skinnier image. We shrunk up the y-axis. The x-axis is still just as long. We're going to go ahead and compile this, load the new image, and then see what this looks like. So as we tweak our images so they're more effective in the game, voila, we now have a skinny car, and the car can still, we still hit the hay bales correctly. Okay, see how that works? Still hitting the hay bale with the tire there. So we have a skinnier car now that's more versatile, but we don't have that 3-direction fixed yet. But that's the retrofit now. That's pretty much the entire retrofit. Besides getting the green images out, and if you make them skinnier, like if you modify your code to use the skinnier 8 image, which we'd seen before, which is this one, go ahead and do that. Change your load. We'll go ahead and do this one just for fun. We have enough time. Let's go down here and let's say we want to load this image. Some of you already have your own images. So just be aware that if you have your own images, and there are various sizes, make sure that the sensor code, see if you have a bigger image, then the sensor code may not make sense. You have to look where the sensors are on your image. Does that make sense? Okay, so if you have more of a round image, you may want to play with your sensors a little bit. Even though there's a little bit white or a little bit of field green out there to cover up the edges, because we're using that technology. So RCASG. So for RC8, we're going to use RC8SG. So I added an S for skinny. That's what I remember doing that. So that's the image for direction 8. Well, we have to change the sensor now, right? Because we were see this sensor out here at X plus 80 makes no sense because 8 is going up, so X is 0. X is right across from the corner for you guys from the corner over here. Okay, from the corner over here, X is 0, right? So we're going to move these over. So probably 10 makes sense. Probably 30 makes sense. And probably 50 makes sense. But also when we load it, because Mr. Thelman changed the name of the image, but did I change my X width? No, I did not. So we have to make that 60 there. Does that make sense? We made it 60 here and 60 there because the images that go that direction, they're skinnier because they're not horizontal. And so if we want a cleaner pass of our objects when we're going up, we do that. So I changed direction 8 there when we're checking to see if we hit the wall, okay? But I'm also changing direction 8 for the hay bale check, right? And there is no direction 8 for the hay bale check. So we're not checking for hay bales when we go up yet. Again, that code needs to be written, but we'll finish that code in a retrofit in one of the future lessons because we're not writing all this code right now. I'm going to show you an easier way to do it. But anyway, that's the big part of the lesson. I want to make sure that we go over this. Modify your code to use PeekMessage instead of dir. Be sure to move dir as a global variable. We talked about that. Be sure play mode is set. We talked about setting play mode. We made sure that let's play init, initialize it to 1. We made sure it was 0 coming in. Just to be sure that in my code, I went in here in the beginning of the program right here that I just said, just to make sure I wouldn't have any, because this is my WN main, I went ahead and just said dir equals 0, and I said play equals 0. So that's one of the things that I did there to make sure that was like that. Clean up bitmaps and finish any perimeter code from last time. See if you can add a moving flag. Okay, and I want to walk you through the moving flag here, and I'm going to do that after a break. So there's going to be a week 7 part 2. This will be week 7 part 1. I'll go ahead and load this and upload this one, and then I'll show you how we add the moving flag and how I did that. And that is the reason why we add the moving flag. I want to show you what the moving flag looks like. So this is an example of what it looks like. Is that we took 3 flag images. Okay, so that as the user plays the game, it's that thing of like we can do something even if the user's doing nothing. And so what we did is we added a little box out here for a flag. And I just want to show you what that code looks like. And I'll show you that code in the next video because I am going to take a little break and it's easier to upload smaller images. This one, and that's what the flag looks like. And now this code is going to act up on me. So let me recompile it because it didn't compile right. It was working. We're gonna see. I love it when my code acts up on me, right? I love this. Now it's acting right, I think. Alright, well, there's the flag. Yeah, it just takes a little bit longer to load. But even though I'm not, this is one of the more, and if I hit spacebar, then everything stops. Spacebar means that we take a break. And that's the other part that we had to add. And we'll add the spacebar functionality and the flag in part B. Okay? So that's what we're doing in part B. This is part A. This is the first half hour of the class. And so we'll talk about adding the flag and spacebar for pause. And that will be the second part of the class. Alright, so we'll get this one uploaded and I'll do the second part here and it'll be maybe like a 10-15 minute video, I hope. But that's what we're going to be adding is spacebar pause. And then so I'll talk to y'all in a little bit. Yeah.